Good afternoon, I'm Hal. From Earth Sensitive Solutions. Before presenting our project, I want to thank Geostar for their sponsorship as well as New York Geo, and specifically Johannes for continuing the Top Job tradition. From its inception, Top Job was intended to highlight the talent and creativity of geothermal designers and installers as well as showcase the virtually countless ways geothermal can be applied to meet the challenges of the 21st century. It is a real privilege to be included amongst the other Top Job presenters, and thank you for your time to listen to our presentation. For both professional and personal reasons, we are thrilled to present to you a geothermal project worthy of the New York Geo Top Job title. Successfully designing and building geothermal systems creates a sense of pride and professional satisfaction. However, some projects stand alone in providing a highly personal level of satisfaction and gratitude to have been a part of. Working with the Central Association for the Blind and Visually Impaired, or CABVI for short, provided an opportunity to help those who help the visually challenged members of our community. Like all major undertakings, it takes a team to deliver the final product. The exceptional team on this project is worthy of top job recognition alone, from Dave, who played the role of architect and overall cat herder, to Jared, the system design engineer, to both Steve and Wade, who applied their expertise to deliver the goods, and the creative leadership of the client, Rudy, who played the role of creative catalyst. It was Rudy's initiative to bring his key staff into a meeting with the design team. Through this listening opportunity, the design team walked away with valuable insight into how the facility would be used, and the challenges of serving their visually impaired clientele. It became clear, the prospect of having a pool generated a sense of anticipation and excitement. There was also an expressed desire to strengthen their connection to the community by opening the pool to the public. This simple exercise in listening gave rise to an unexpected opportunity to showcase the incredible flexibility of geothermal. The difference in temperature between therapeutic and recreational use resulted in the geothermal pool heating system also becoming a pool cooling system, so that both temperature requirements could be achieved. The first step was to determine feasibility and associated economics. Using the physical size of the pool, the desired temperatures, as well as the heat pump operating characteristics, an energy analysis was performed. From a cold start, it was determined it would take 15 tons of capacity to heat the pool in 3 days. Using this 15-ton size, it was then determined that the pool could be cooled from 91 degrees to 86 degrees in 7.7 hours at a cost of $12.85. Returning the pool to 91 degrees would take 8.7 hours and cost $17.46. These results were presented to the owner, and it became clear that geothermal became the winning solution, and nobody mentioned the word boiler again. The anticipated schedule of 3 days open to the public and 4 days of therapeutic use was then folded into the overall loop field energy model. And now, this beautiful facility is serving their clientele and their greater community. And this was just the beginning of capturing the magic of geothermal. The magic of geothermal is accomplished when multiple thermal loads are served. In addition to pool heating and cooling, Jared's analytic and creative skills led to including the pool deck radiant heating, dehumidification of the pool room, space heating and cooling of the building, harvesting the heat from the computer room, snow melting, as well as heating the detached maintenance garage. There are many heat recovery opportunities and synergies that occur which result in significantly improving the cost-effectiveness of a project. If individual standalone systems had to be installed to handle each of these thermal loads, there is no doubt that both operating costs and initial costs would be significantly higher. These thermal synergies were analyzed, and loop field sizing was optimized, further improving the overall cost effectiveness.
Step aside, Hal. This presentation, as well as the entire geo industry, can benefit from a woman's touch. Hello everybody. My name is Eleanor and I will be taking over the presentation. A quick shout out to my Geo sisters, Lisa, Tracy, Kathy, Amanda and Courtney. Keep up the good work. Now, back to CABVI. The first step in integrating the various thermal loads is not only quantifying the peak load, but more importantly characterize and model each load on an hour-by-hour basis for a typical year. The zoning floor plan illustrates the variety of space heating and cooling nuances. For example, interior zones will have minimum heating requirements whereas the perimeter zones represent the majority of heating. Applying the appropriate equipment is key to optimizing performance and comfort. For the majority of spaces, Samsung's water-cooled DVMS product line, a VRF, or variable refrigerant flow product, combined with their heat recovery accessory MCU, or mode control unit, created the opportunity to allow the heating of the exterior to simultaneously cool the interior. This direct heat recovery technology and corresponding improvement in system efficiency significantly reduces the overall load on the loop field. The ideal choice for large spaces with a very large swing in the cooling load, such as the multi-purpose and fitness rooms, the packaged variable speed GeoStar Sycamore, with its inherent superboost mode has a turn-down ratio of 6.5 to 1 before the unit has to start cycling on and off. Therefore, the inefficiencies and adverse effect on reliability associated with the stress of cycling are avoided over a very wide range of cooling loads. Both the GeoStar Sycamore and the Samsung DVMS use variable speed compressor technology and directly control a modulating valve to reduce the water flow to the minimum required amount. Consequently, the centralized pumping solution has to have turn-down capability that matches the full range of expected flow. This Phoenix Energy Supply Flow Center met those requirements as well as being a compact design to fit into some very challenging space constraints. Developing the system schematic is a critical and vital step and becomes the foundation and a roadmap to specifying the hundreds of details that can make or break a design. From pipe material and sizing, to valves and pumps, the system schematic is a critical tool in every design. At CABVI, this schematic illustrates the 3 Samsung DVMS condensing units. A separate schematic illustrates the refrigerant piping and the various DX fan coils as well as the heat recovery modules. The 6 packaged water-to-air heat pumps. The 7 water-to-water heat pumps for snow melting, pool conditioning and heating the maintenance garage via in-floor radiant heat. The flow center providing the ultimate in pumping efficiency using 2 Grundfos Magna 3 ECM variable speed circulators. The loop field energy model resulted in 12,000 feet of vertical bore was required. The 24 500-foot bores were laid out in 8 groups of 3 bores each. Each bore has a 1 1/2 inch loop. The grouping provides for a robust design, and to minimize pressure drop 3-inch pipe was used for each pair of supply and return piping. The 3 inches reduced to 2 inch just prior to entering the building. This short length of 2 inch has an acceptable pressure drop and allows for a more cost-effective interior valved manifold by using 2-inch valves. Speaking of the valved interior manifold, the return manifold has the 8 circuits. As you can see, there is a 9th pipe, which runs over to the maintenance garage to supply source fluid to the 2 water-to-water heat pumps. The supply manifold includes the return from the maintenance garage which mixes with the return from the heat pumps in the main building and is sent back through the 8 circuits returning to the loop field. Please notice that there are no balance valves on the manifold. Our experience has shown that balance valves on a loop field simply add cost and pressure drop and provide no value. Our sister company Phoenix Energy Supply designed and fabricated the manifolds and flow center to fit into a very tight mechanical room. Using our system pressure drop modeling software, we can quickly determine the required head pressure of the pumps at the full load diversified flow rate of 256 gallons per minute. As you can see, the total pressure drop of the CABVI system is 37.4 feet. Our preferred pump selection philosophy is to use 2 pumps in parallel to provide a degree of redundancy as well as very high efficiency under all load conditions. We selected the Grundfos Magna 365-150, which under full load uses 1300 watts each. Full load requires both pumps for a total of 2600 watts for this 110-ton system, or 23.7 watts per ton. Both Hal and I, as well as everyone at Earth Sensitive Solutions, would like to thank you again for listening to our presentation. If you have any questions, you can reach us at info@earthsensitive.com.